Okay, so the first part of the PowerPoint we did together as a class. It was great, right? So now this is kind of the background information that you need to know for your first four example problems, which is pretty exciting. So let's talk about some translations on the coordinate grid now. We've explored a lot with translations in the real world, which is cool. But now let's talk about on the coordinate grid. Okay, so the first thing we're going to talk about is the pre-image. Okay, this is going to be the original figure before a transformation has taken place. So the figure will always be called the pre-image before it has moved around. Okay, another word for pre-image is the input, which again are the original points of the figure. This can also be called domain. So we have pre-image, inputs, and domain. Holy hot dog, right? Three things mean the same thing. What's going on? All right, so like for example, points H, G, and F make up the pre-image triangle. So the inputs or our domain are actually the points H, F, and G. So this is the shape before it has moved all around. So get excited. Okay, now after the figure has moved, which in this section we're going to talk about when they translate, which is when they slide. After the figure has moved, the final spot where it has landed, that shape is called the image. So this is the figure after the transformation has taken place, and primes are placed over the points of the image. So like points H, G, and F, after it moves, the way you can tell it's the image is by these little prime things. They're actual like apostrophes, but you know, mathematicians have to be special. So instead of calling them an apostrophe, we're going to call them a prime. So if it moves one time, all of your points will have a prime. If it moves two times or has two consecutive transformations, we'll have two apostrophes or like kind of like a quotation mark kind of. But we're not going to call that because we have to be special since we're mathematicians. So we're going to call it a double prime. So if it moves twice, we're going to have a double prime or two little marks above the point. So like and again, other words for the image points are the outputs. So the points are called the outputs in the range. For the pre-image, they're called inputs and domains. So watch yourself. So the outputs are the points of the new translated figure or the range. So after the figure has moved, the new points are called the outputs or the range. And these make up the points of the image. So like if you guys see here, when it moved, H transformed into H prime, F transformed into F prime, and G transformed into G prime. So after you translate a figure, those primes will appear. Pretty cool, right? All right, let's keep going. Now, one way to represent a shape translating is by something called a vector, which is cool. So a vector is a quantity that has both magnitude and direction, which magnitude simply means just the length. So something will travel for a certain length in a certain direction, and that is all that a vector is. Okay, so vectors always have a start point, which is called the initial point. And then where the point lands is called our terminal point or our end point. So initial point is our start point. End point is called the terminal. So they have fancy names for vectors when you start and end. Pretty cool. So if you love the movie Despicable Me, if you remember, there's a villain in the movie that fights bad guys, or he fights people he's opposed to with magnitude and direction. And his name is Vector. So I'm going to show you the little clip from the movie that shows you about vectors. So it's pretty cool when like Disney movies include math terminology. So I'm going to take advantage of that whenever I can. So let's watch this fun clip of Vector fighting with magnitude and direction.
It's a mathematical term, a quantity represented by an arrow with both directions and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah!
Board slapper.
Hurrah! You want a demonstration?
But anyway, so that's Vector. He's pretty cool. He fights with magnitude and direction, so it's pretty awesome. But anyways, I just thought I would share that because it was kind of fun. And of course, it's not going to let me go. Okay, well, it'll be okay. All right, let's keep going. Okay, so again, we use vectors to translate. So, for example, this tells you how much to move the x value. So when we use vectors, we don't use parentheses. We use these like fancy like pointy parentheses. Like if you touch the end, it'd be like, ah, that hurts, right? So don't touch that. But anyways, we use these to denote that we're talking about a vector. So if you ever see this weird pointy parentheses, that means you're dealing with a vector. So be careful. So the first spot, so this is not a point. So be careful. This is not a point that you plot on a coordinate grid. Okay, this tells you, the first value tells you how much to move the x value, either left or right. And the second value tells you how much to move the y value, either up or down. So it kind of tells you which direction and how far to move your original point. So again, it moves with a magnitude and a direction. And this is called the component form of a vector, which later on, when you get higher up in math, you'll learn about different forms to represent a vector. But you'll learn about that later. So we use this little symbol. We're not going to really use this in this class, but I just thought I would share it with you. We use this little like half arrow looking thing when we're talking about vector. So this means vector xy. That's what that little symbol means. And again, it always starts with your initial point. So x would be our initial point, and y would be the end point or our terminal point. But this stuff we're not really going to be using in this class that often. I just thought I would share it. So again, the component form, this form right here, tells us how far horizontally, which is the first one, and vertically, the second one, the vector will travel from the initial to the end point. So like here, the first value tells us how far, in this case, right, it's going to move. And then, in this case, how far up it will move. So it moves right and up, which makes it kind of move diagonally. But that's just kind of what's going on behind the scenes. We're not really going to do this a whole lot in this class, but it just kind of gives you an idea as to what's going on. Okay, so we're about to start example 1. So you will need this piece of paper to do example 1. So follow along on example 1 to figure out how we use translations to move things around using vector form and the algebraic rule. So go ahead and pause this video and watch example 1.